we have planned to do is just we'll revise chemical properties. But if you're discussing, for example, and you want to go in depth or you have doubts in it, then we can discuss there only. Okay, so you would have to help me out in that. I'll keep on discussing all the concepts which are there, not in detail, but they try to complete chemical properties of alcohols and maybe preparations also if the time helps us, right? For example, Grignard reagent, lithium aluminum hydride in this 1 hour. So whatever I can try to do, I will do it. Okay. But if there is a certain topic and you're more curious about it, we can discuss further on it. Okay, I won't discuss much mechanism. I'll just brief you like what is coming for the test and everything, right? What all topics are important, everything that we'll discuss a bit, not in detail, but how it goes by simple methods. Okay, which might recall you how things will work for the test also. But if you have a doubt, obviously you will ask me. If you want to go in detail, I will discuss it. Any question, anything you want to ask, that you can ask. Okay. See, first we'll start with acid ignification since we are talking about chemical properties. We'll start with acidic nature of alcohols. Okay. Now we study alcohols or maybe phenols also is coming, right? So I will teach you both. Okay, let us maybe this is the most important ones. But before we start, I will teach you one thing, okay? A bit out of context, but this will make our life very easier. I'll tell you a few tricks that actually helps us out a lot. Okay. Imagine when we compare the acidic strength, okay? This is the order of the acidic strength which I am giving you. Okay. I would have given in respective classes also, but since you are new, I'm not giving the exact order, but few order I am giving it to you so that you will remember a bit. For example, picric acid comes, then NO2. I'm telling you, I'm not giving the entire. There's a big order on it which we have to memorize, but I'm not going into it. Okay. Then what will come? RC acids comes. This is the order of acidic strength. Okay.
Sir,
In
are you writing?
It's not visible.
No, sir. Oh, now it is.
This is for everybody else is visible.
Yes.
Okay. So RCOH. Amog, what are you doing here, man?
Sir,
What are you doing here?
simply just want to join
You're Amog from TFS or from different Amog?
NPS.
Oh, sorry. Acha, NPS one. Oh, my bad. I was taking as a TFS one. I was actually taking his doubt class like 10 minutes back only. That's why I was asking. My bad. Okay. So very small concept, RCOH, very basic stuff we are doing over here. I'm just recalling what chemical properties are. Okay, RCOH looks like what? What is RCOH? So HCOH is more acidic, then PHCOH, and then what is acidic? Then the normal RCOH will CS3COH and everything. Right? Normal alkyl COH, what I meant. Then in the order what comes? S2CO3 comes. S2CO3. Okay. And then other phenols also come that we are not taking into account, but phenol will come. Normal phenol comes.
So we can't see you right. Like when you're going full screen, we can't see you right.
Is it same for everybody?
Yeah, sir.
Yes.
What is wrong? Wait,
So when you minimize, we can see what you're writing, but when you're full screen, we can't.
why is that? Is this fine now?
Yes, sir.
You can see
Yeah.
everything.
Yes, sir.
Okay, I'll correct this issue. Okay. Then phenols will come. Then what comes? Alcohol comes. Okay. So what is the order of alcohols when we look at? First CS3OH is there. First CS3OH is there. See, I'm trying to tell you the acidic nature. So we don't have to learn over here. So that will make our life throughout organic easier. That's why I'm telling you this. Then CS3OH will come. This is more acidic. Then water. And then our anything alcohol other than CS3OH. For example, ethanol. Right. Then what will come? Our NS3 comes. Right. Something like this comes. Okay. Here, alkynes are everything is also there, but I'm not discussing right now. This will work for us. Okay. See how this works, that I will tell you. How this will make our life very, very easy. So this is the acidic strength order entirely, right? So now first this is SO3H, then acids come. After acids, H2CO3 come, then phenol comes. After phenol, general alcohol comes. Okay, I will draw like this. But this is more acidic, na? My bad. Drawn it. Like this. Okay. So this is the acidic strength. RSO3H, then RCOH, then H2CO3, and then phenol, alcohol, NS3. And in alcohol, first ROH is acidic. Sorry, CS3, methanol is more acidic, then water, and then any alcohol other than methanol. Now, why did I tell you this? This is not related to our topic, right? See how this is more related. How will you remember everything in acidic nature? Now imagine I take phenol, or let me take any ethanol, for example, CS3, CH2OH. And you react with NaOH. Famous reactions which are there, famous previous equations also, right? NaOH. So this is a base and this is our weak acid because H is attached to what? Electronegative element. So first reaction that will happen is acid-base reaction. So what will happen? Turn into CS3, CS2, O negative, right? OH negative and H will react, right? And Na will come over here and water will be formed. Okay. Now this is what? Our when we call this is acidic nature of alcohols. So let's ever make life more easier how to remember it. Now from the brief thing we know, right? Generally the normal alcohol there, which is more acidic? Water is more acidic than the general alcohols, right? So what will happen over here? When you look at very carefully, here what is formed? Water. Here what is there? Ethanol. So water when you check is stronger acid as compared to ethanol. See? Water is a stronger acid as compared to ethanol. And the reaction can always go from what? Stronger acid to weaker acid. So even without memorizing, you can say what? That this reaction is not possible. But if I take phenol for example, since we are talking about phenol, and let me react with NaOH. Right? So what you will get over there? You will get acid-base reaction. OH and H will react, right? HO negative, H plus negative. So this water will react. And you will get what? O negative Na plus water. So now check. This is what? Acid. This is our what? When we compare, right? This is weak acid as compared to phenol. So weak acid as compared to this is strong acid. So reaction is possible from stronger acid to weaker acid. Makes our life Oh
You
my,
went full screen again.
yeah, my bad, my bad. So reaction will go what? Here the reaction, what will happen in the reaction? This reaction is also feasible. I'll repeat what is happening. This is ethanol. Weak acid. When we go from the previous slide, what we'll have, what we have seen, water is there and ethanol is there, right? Anything which is apart from ethanol, right? So which is a better acid? Water is a stronger acid as compared to what? Methanol. This will help you in GOC too also, like where we compare acidity, basicity in the questions, right? So this acidic strength makes our life more sorted in that questions also. Okay. So H2 hai, so H2 is stronger acid as compared to weaker acid. So that means what? But we can only go from what? Stronger acid to weaker acid. That is our criteria. So this reaction is not feasible. But when we look at this over here, right? Here water is formed. So when we check from the previous slide, right? That phenol is more acidic than what? Water. So this is our what? Weaker acid. This is our stronger acid. So this reaction is feasible. Is this clear? Divija, is it clear to you?
Yes, sir.
See, more reactions. See, this will make our life more easier. See, CS3, CS2, OH plus NaNH2 is there, for example. Or let me pick something more difficult. NaHCO3 is there. So sodium bicarbonate act as mild base. Okay, baking soda. And phenol is also there. Phenol can react with NaHCO3. Right, let's see if it reacts or not. Let's see. Now what will happen? NaHCO3 is there, right? Acid-base reaction, this will be acid, this will be base, right? So what will be produced? Na plus HCO3 minus, this will be H plus minus, right? So positive, negative will attract each other. What will be produced? H2CO3 will be produced. And up will be CS3, CS2, O negative plus, right? Devaja, tell me, is this reaction feasible or not? Arsh is there. The first reaction is feasible or not?
So no.
No. Why? Because when we look at from over here, right? H2CO3 is a stronger acid as compared to whatever alcohol, right? So this reaction is, because this is strong acid, weak acid, reaction not feasible. So instead of memorizing, this will make your life more better. Is that fine? Then over here, when you look at the phenol over here, right? H2CO3 is again acidic than what? Phenol, strong acid, weak acid. You can see it from this table to remember. Right? This is more acidic as this, right? So again, the reaction when we see is not feasible. Is this clear to everybody? Better let me know so that I can proceed ahead. नहीं बोलेगा कोई. Amog,
Yes,
beta,
sir.
Amog, is it clear to you? Go. I will ask myself. Arsh, is it clear?
Yes, sir.
Okay. Gauri, is it clear to you?
Yes, sir.
Okay. Riya, is it clear to you?
Yes, sir.
Okay. For example, we'll pick something else. CS3, CS2, OH, and we react with NaNH2. So what will happen over there? CS3, CS2, O negative Na plus NH3. So NH3, when we check in the table, it's weakly acidic, the weakest, one of the weakest acid. And this was what? Strong acid. So this reaction is feasible. And same thing will happen with what? Phenol also, H will come out. NaNH2, NH2 negative will be there, positive will be there, and you will get what? O negative plus NH3. Is it clear? So this is also weak acid, strong acid. Reaction is feasible. And other reactions which are there with Na, whatever produces H2 and all that, you will do it yourself. Then there is esterification reaction. This we do it in what? Acidic medium. Right? So imagine RCOOH is there. This will react with our alcohol in the presence of H plus. So what happens? Water leaves. Oh, this OH or from this OH something will leave. Okay, let me show you like this. Okay, water will remove this water, this have to remove. Water will get removed and you'll get what? Ester. Plus water. So Ria, tell me, I am saying water will get removed, right? So there are two possibilities of water getting removed. Either this OH will leave, OH will remove, and this H will remove. Right? Other possibility is what? Let me take the black one. That this H is going and this entire OH is going. Right? So which oxygen is whatever this oxygen is, right? So which one will we go with? Blue one or the black one? Which OH will go? This OH will go or the RCH2OH will go? Which OH will go, Ria?
The blue one.
The blue one, right? Exactly. So basically, what is the funda when we talk about RCOOH plant RCH2OH? What will leave? OH will leave. This OH leaves, and this is very, very important. And here, what will go? Only H will go. So this oxygen which is over here, right? This belongs to what? Alcohol. Because this OH is leaving over here. Is that clear to everybody? I'll repeat it again since this is the revision class only. So RCOOH plus RCH2OH. This OH will leave and this H will leave, forming what? RCOOCH2R. So this oxygen is this oxygen, this one. And this is very, very important to know for the exam. Is that clear? One more thing which is important for the exam is this. Imagine you take this CS3CH2OH and you react with what? CS3COCl. Right? This can happen in the presence of NaOH. Phenol. And, or maybe let's take this only. The next. Let's take alcohol only. And you react with CS3CO. This is called kind of what? Scott and Bowman reaction also. Very, very important. Either we take NaOH sometimes or we take PY. PY is pyridine. Pyridine is also a base. How does pyridine look like? Something like this. Base. Lone pair will be there, which can go and attack. So Lewis base. So here also pyridine, NaOH. Anything can be there. Okay, in the exam. So tell me what will be formed over here. What is the name of the compound? Anybody can help me out. Better somebody has to tell me, otherwise I will ask. So better somebody tells me. If you don't know it, tell me like you don't know it, or try to attempt it what you're getting, right? Or tell me what function group you will get.
So will it be an ester?
And can you help me out? How did you do that?
Sir, you remove the H and so can you show the question again?
Wait. Yeah. Yeah.
Uh, so you do substitution and you remove. No, you eliminate the Cl and connect it at the O.
See, generally what acid-base reaction happens, right? First, then what happens? Nucleophilic addition. If some nucleophiles are involved, okay. And last, what happens? Nucleophilic substitution happens. Okay, leaving it aside, what will happen? See, here some partial positive will be there, right? This is called nucleic acid-base reaction, not possible till now over here. So what will happen? This will go over here. This will go up. This will come back. I'll show you how the mechanism goes by. CS3CS2OH plus CS3COCl. Here some partial positive is there. Here lone pair is there, right? So this will go attack over here, and this will go like this because Cl could have also left after attacking this. Carbon can make only 4 bonds, right? But it's easier to break a double bond rather than what? Single bond. So what will happen over here? CS3, CS2, O, CO, sorry, CO negative, Cl, H positive like this. Something like this will come, right? Oh, CS3 will be also there. Always remember when Cl is there, Cl is always there to remove to get removed, right? So this negative will come back again, and this will leave. So we can directly predict also that this is going to leave only Cl. Okay, it's just that we have to be, and this H plus will get removed by what? Base, right? So O will come, CO, CS3. So this is also kind of what? Esterification reaction, another way. Right? Other thing that we can do is this. For example, this is there CS3, CS2, OH is there. Right? What will happen over here? This will react with what? CS3, CO, O, CO, CS3. This is also a good leaving group, right? So we can see directly this will react and this will leave, right? Something like that. Elimination will only happen. But the exact mechanism is this. For example, in the boards or something, they ask, right? So this will go like this. First mechanism will be CS3, CS2, O, H positive will come. We'll tag the C, right? O negative will come, CS3 will come, O, CO, CS3. So this is also good leaving group. So this will come over here and this will leave like this. You'll get what again? The base will take this H plus, you will get what? CS3, CS2, O, CO, CS3. Is that clear? So this is again what? Ester in a different way. Again, we are forming what? Ester with other components using alcohol. So these are other kind of esterification reactions. Same thing will happen with what? Phenol also. But phenol is very acidic as compared to what? Alcohol. So first what happens? NaOH reaction happens. NaOH bhi hoga, right? A base will be there, right? Or simply if we don't even apply it, things will be same only. But generally what happens, for example, it's first acid-base reaction is happening. O negative, right? Now what will happen? CS3COCl is there, becomes very reactive. This will go over here like this. This will go up. CO, like O negative will come like up. CS3, Cl. Cl is always there to leave. This will come, this will leave. And you will get what? Again an ester. So if you clearly observe, right? Here, first I attacked this and in the end we removed H. Over here, we first removed H. First step was what? As first we did acid-base reaction because acid-base reaction faster, right? But here we are not doing that with NaOH, for example. Can anybody tell me that? Why? H we are removing in the last stage and here H in the with phenol H we are removing in the first place. Okay, even though the answer will be same. So even if you don't like just get it that how what is the product, things are fine. Okay. But can anybody tell me why I'm changing the mechanism? Think and let me know why I'm changing the mechanism. See what happens. Imagine you take an alcohol, CS3, CS2OH with NaOH. You will get what? CS3, CS2O negative, Na plus water. And we know water is a better acid, stronger acid as compared to what? Ethanol. So this reaction is not feasible. But reaction with phenol, as we discussed, is feasible. Right? That's why the first state is what is formed? Phenoxide ion, which is very, very reactive. Which reacts further to form what? Ester products. And this is called Scott and Bowman reaction. Is it clear?
Yes, sir.
Okay. Then I will take another chemical properties, which is what? Lucas test. What happens in Lucas test? Detection for 1 degree, 2 degree, 3 degree alcohols. Okay. How does the mechanism goes by? Very simple. First, first I'm telling the tricks. When 3 degree alcohol is there, just making revise a bit, that turbidity comes immediately. Immediately. It can be 3 degree alcohol or it can be formation, for example, some benzyl, allyl, something like this is there. That will always give turbidity immediately. And 2 degree alcohol will give us what? In 10-15 minutes. And 1 degree alcohol will give it more than 30-40 minutes or won't give only. But this is the average which is there. The turbidity appears in what? A very late. Okay. See. So here generally it's not there only, but yeah, let's see how it mechanism works like simply. Imagine RCS2OH is there and you react with H plus. You'll get what? RCS2, obviously H will go and attack this oxygen, right? Lone pair, positive, always rich attacks the poor. This is what we are doing. Rich is attacking the poor, right? And H2O plus is a very good leaving group. So as soon as it leaves, you get a carbocation. You'll check for any rearrangement possible. Right. So since there is a formation, now what will come? After that, when everything is done, right? So you get what? RCS, basically, you take what? What is the reagents? I tell you the reagents proper. Conc HCl. The H plus is coming from over here. Cl negative is already there, right? And anhydrous ZnCl2. So now Cl negative will come, which is left over of this, and form RCS2Cl. So more stable the carbocation formed, more the rate of more stable carbocation. More the rate. So we know that 3-degree carbon is more stable than 2-degree than 1-degree, right? That's why over here, when 3-degree alcohol is there, it will give us stability immediately. 2-degree alcohol will give in 10-15 minutes, and 1-degree will alcohol will give in 30-40 minutes. Is that clear for everybody? If you want, I can give you a lot more questions. Okay. But we will just revise. If any doubts, you can obviously ask. Okay. Then what is their dehydrations of alcohol? Very, very, very important. I've never seen a mains paper without this concept.
So you went full screen.
Oh, my bad, fair say. Uh, So we've never seen a paper without dehydration. Dehydration is elimination. You would have done it in the previous organic class, but I'm just revising a bit. One more for 5 minutes. And this generally goes with what? Via E1. Generally, it goes with via E1. What are the reagents that we have to see over here? Reagents are very, very important because the mechanism can change via E1. Okay. What is that mechanism? See. Reagents which will undergo E1. It can undergo E2 also, E1 CB there is a mechanism, but we won't go into it. For example, when we have to do H plus, heat is given. Or imagine Kong H2SO4 is there and some heat is there because we would have to eliminate something. And heat is there. Or Kong S3PO4 also they use. Is that fine? The point is what? All will liberate us what? H plus, because this will liberate H plus. And S3PO4 will also liberate what? H plus. Right? So the point is we are liberating what? H plus and heat, which will undergo what? Heat is important for what? Elimination. Right? So how it goes by, if I have to pick a very easier concept, easier funda. Yeah, you're saying something, Abhay?
If you have to liberate H plus for this, then why can you use Al2O3 and all?
That is different, beta, because that will act as they will have a surface on it. Okay, and they will give E2 over there. Is that fine?
Okay.
Acha,
So it's not always even.
So it's not even. Al2O3 is not even.
Okay.
Okay, I will tell you how it goes. Next, I will tell you. Okay. So imagine if this is there. Okay. And you give H plus heat. Right. Or you give Kong H2 over Kong S3PO4. So obviously we know electron rich attacks the poor. Positive will come. And this is a very good leaving group. So this will leave. Simple. Positive. Now you will check, since we have formed carbocation, right? Always when we have formed carbocation, we check for what? Rearrangement. We always check for what? Rearrangement. So here rearrangement will happen. What can happen? This hydride is there, right? So this can shift. So to give a more stable carbocation, which is 3-degree carbocation, right? H will come over here. Now can we rearrange something else? The point is no, because we already have more stable carbocation. We have 3-degree. We cannot do anything else. Once we have done it, right? So how will we eliminate? We will eliminate beta H. Always remember, we'll eliminate what? Beta. What is beta? This is alpha. This is beta. This is beta. This is beta. So two kinds of product can be formed over here. One is I'm removing this beta. Always beta H will be removed, right? So this beta H will get removed, will come over here. Like this 2 electron, H positive will come, this 2 electrons will go over here. So one is this. Other product feasible is what? This one. Both will mean the same thing if you take it from here or here, right? So this is, which is the most stable product, right? This is called ZZEP, more substituted. And this will be our major product. Both will be produced. And this will be our minor product. And the minor product is called what? Hoffman. I hope it's clear to you. Is that fine? You know it, this all stuff, right? So exam mein don't mess it up. Okay. Abhay, what you were saying, right? E2. It goes, dehydration happens with E2 also, and the reagents are what? Al2O3 heat,
Yes, sir.
T2O5 heat. This is the surface for elimination.
So you put it in full screen.
यार, क्या कर रहा हूँ मैं? ठीक है, and this all will be what? P2O5 all will be what? When we talk about this, all will give us what? E2. Is that fine?
Yes.
Other thing that you should know in the chemical properties, which is very basic and important for the exams also, for your boards exam, any exam, right? That is important, which is called Darzin's process. What is Darzin's process? For example, ROH is there, and you give SOCl2. You will get what? RCl. Simply.
RCl plus SO2 plus HCl.
Yeah, in a bath. And why this is the best method to
Sir,
prepare?
because it liberates SO2 gas.
Yeah, this is SO2 gas and HCl gas. So only HCl बनता है, H2O बनता है, if I'm not wrong. H2O बनेगा ना?
No HCl, no sir, because एक Cl तो आपने R में दे दिया और बाकी
Right.
HCl जो बचा हुआ है.
Makes sense. Right. My bad. ठीक है. तो ये हमारे हो गए ROH, SOCl2 और ये हमें मिल जाएंगे. हमें क्या बना के दे देंगे मजे में? गैस बना के दे देंगे. ठीक है. और यहाँ पे पर जो RCl होगा, this will be our one of the best one. When we talk about this stereochemistry, mechanism is SNI. What does SNI means? That a reaction will go with what? Retention of configuration. Now, what is retention of configuration? That I will tell. So, if, for example, if this is there, or I will tell you one more mechanism. I'll come into the, what do we call it? The stereochemistry. For example, if this is there, CS3, CS2, OH, and you react with PBr3. Right? So here you get what? CS3, CS2, Br plus S3PO3 निकलता है इसमें से. ठीक है, one of the side products. But what do we have to remember? Over here, this mechanism goes with what? SN2. Right? You would have another mechanism also, this SN2. So what is the difference between SNI and SN2 basically? So when we look at the mechanism, for example, some different HDT is there, for example, like this is there. C, D, T, and OH is there, right? C, H, T, D, and some leaving group is present over here, for example, OH ले लो, right? If the reaction is happening with SNI, for example, you go with what? Retention of configuration. For example, SOCl2.
So your full screen.
Oh my bad, यार मैं क्या कर रहा हूँ? Okay, SOCl2, right? So C, H, T, D, and what will come over here? Cl will come at the very same position. This is called retention of configuration, right? But if SN2 would have been happening, right? What will happen? Inversion from the back. So one nucleophile will come from the back. And this TD will move like this. So this is called what? Inverted product inversion. SN1 ka to, you know, carbocationally formed and everything will go by. Right? Simple. So you would have to remember this few mechanism, important mechanisms. Other oxidation reactions. Now when you oxidize alcohols, you use two types of oxidizing agents. One is
Strong and weak.
mild, not weak, mild. And we can use strong. What are strong ones? H plus KMnO4 and heat. We give heat also. Or we give what? H plus K2Cr dichromate, K2Cr2O7. Then we can use Jones reagent. It's called what? Jones reagent. Jones reagent हमारा क्या होता है basically? With it's CrO3 in the presence of H2SO4. This is our what? Jones reagent, a very strong oxidizing agent. Mild में there are many, but what is the main one? PCC. PCC stands for pyridinium chlorochromate.
Sir, even PDC, right?
PDC is also there. PDC full form is what? Pyridinium dichromate. Okay. So if I, for example, if we do some questions, or try these questions, I will give you the questions. Try it yourself. For example, what questions I can give it to you? Okay. Basics. PCC. What you will form? Try. Cu is also a mild oxidizing agent. This is what? Mild oxidizing.
Oh, so Cu with the heat.
Cu with heat, right? What is the concept of Cu? Since this is given in NCERT also, it becomes important for all the exams. What is the concept? Imagine CS3, CS2, OH is there. And so basically what happens, I will explain you the gist only, so that if everybody knows about it. Imagine this is there. R CS2 OH is there. When you mildly oxidize means what? Either loss of hydrogen or gain of oxygen, right? So here if you do oxidation, so what will happen over here? You will give us what? Oxidizing agents, right? So if it's mild, for example, so first will happen this. See what has happened over here? I have lost two hydrogens, one from each HH, right? This is called what? Oxidation. So we're oxidizing it, right? So from alcohol to aldehyde, we get what? Oxidation. When we when we oxidize further, right? So what you will get? You will get RCOOH. Is that fine? So see, we have added one oxygen, right? So both are what? Oxidation only. Is that clear? So what will happen over here when we look at it? When when RCH2 and you use a mild oxidizing agent, what do you get? RCHO. And when you use strong oxidizing agent, you get what? RCOOH. But in Cu, what happens, and this is the part of NCERT, see, CS3, CS2OH, this will get, for example, using a Cu only. This acts as what? Mild oxidizing agent. Will turn into what? CS3COH, aldehyde. Now, when you take 2-degree alcohol, for example, this, you will get what? Cu heat. Is that fine? This will turn into what? CS3CO. You're removing those two hydrogens, right? Oxidation, and you will get what? CS3. That is good, right? Now, when you do what? When you take 3-degree alcohol, So earlier we were removing what? One H from here, one H from here. Here also we removed one H we removed from here. Now we do not have any H, right? So here oxidation is generally not feasible. Oxidation doesn't happen only in 3 degree. Is that clear? But instead what happens over here? Elimination happens. Only in the case of Cu. Is that fine? So what will happen over here? CS3, CS3. How elimination will happen? See, बीटा एच तो ध्यान रखना हमेशा लाइफ में, तो बीटा एच से निकलना एलिमिनेशन हमेशा, राइट? This H, OH, this comes like this and this leaves. So you get what? CS3, CS3, double bond CH2. This is the part of NCRT also. This has become very, very important. In other reactions, elimination product is not, no reaction happens only. But with CO heat, what happens? Elimination happens instead of oxidation. For example, others are there. Imagine something like this is there. With 3 degree alcohol and you give H plus H2SO4. Sorry, H plus KMNO4. So no reaction will happen at all because this is 3 degree. But if it's 2 degree, for example, OH, right? I'll write it down properly. CS3, C, OH, CS3, H. Now what will happen? You will get to what? H plus KMNO4, for example. So we'll remove this H, it will form what? CS3, CO, CS3. But in secondary alcohol, even if we take mild oxidizing agent, right? So ketones cannot be further oxidized. This you have to remember. Or they can be further oxidized only at harsh conditions. But in normal conditions, they cannot be further oxidized, right? So reaction will stop over here only. Okay. But if we use what? Instead of K plus, we can use mild oxidizing agent also. For example, if we use CO or any PCC, anything we use, we again get what? Ketone only. Because ketone cannot get what? Further oxidized to acids. Only aldehydes get further oxidized to what? Acid. Is that clear to everybody? Anyone who is doubt over here? Okay, I'm taking it as a no. Then I will go back. Yes, Nihar, beta bolo.
So after prolonged exposure, don't we get this thing? Like if we have a mildly strong oxidizing agent or a strong oxidizing agent, and in the case of mildly strong, if we keep the ketone, like for prolonged exposure, don't we get acid?
Yeah, if you want to study more about it, it's called Popov oxidation. You can study about it. We can do it oxidized, but in the normal conditions, we cannot do it. Very high temperature, very harsh condition, sometimes pressure also. Then the reaction go by. It's called Popov oxidation. You can just go through it once. Is that fine, Nihar?
So like if other people don't have any doubts in the end, could you just do it? Because I didn't understand it when ma'am taught.
Okay. So basically, see, but anybody else who has doubts over here? Basically, in this lecture, we are asked to take the revision for everybody, right? To revise. Okay, give me 1 more minute and let me complete this topic. Okay. Now what will happen over here? We took this, right? So PCC will turn into what? This O. Okay, because this will be aldehyde. This will form into acid. Okay, because this is first internal to aldehyde, and aldehyde is 1 degree. Alkyl will turn into aldehyde, aldehyde will turn into what? H2SO4 is not there, KMNO4 is there, my bad. Strong oxidizing agent turn into acid. And this is mild oxidizing agent, so this is 1 degree, right? So it will stop at what? CHO. Is that clear to everybody? अब कुछ कोई बोलता भी नहीं यार, हाँ या ना तो बोल दो यार कोई।
Yes.
ठीक है। पॉप ऑफ ऑक्सीडेशन क्या होती है? सॉरी,
नथिंग सर।
okay. So what is Popov rules when we check, right? That is specifically in ketones, right? So if you want to study, बताओ ना, चलो ठीक है सुन लो. What happens? See, very simple only, okay? RCH2, CO, CS2, R dash. You do H plus KMNO4 high temperature you use generally, okay? So or maybe we can use conc HNO3 also, right? So it can cleave by what? Either this cleavage, it has to cleave, right? So it will cleave by this way, for example. So it will form what? RCH2, COOH. And other also will form what? RCH2, COH. All has to form. You cannot increase the number of carbon atoms, right? COH. Other way of breaking it apart is what? It will break over here, right? It can break from anywhere. It's their wish on where it will break, right? So generally it breaks from that position. For example, if this is the one, right? CS3, CS2, CS2, CO. How will we break this, right? We can break from two ways. CS3. So either we can break from here, it'll make two lines. Or either we can break from where? Here, right? So where we have to break? So the rule says that oxidation of unsymmetrical ketone hota hai jab, right? This is unsymmetrical ketone, right? Is cleaved in such a way that keto group stays with a smaller alkyl group. Keto group stays with a smaller alkyl group. So if this has to break, right? What will keto group has to stay with a smaller alkyl group, right? So we'll break what? The blue one. So here the answer will be what? CS3, CS2, COH. Number of carbon atom won't change. It will remain the same only, right? And what will happen? CS3, COOH will come like this. But this carbon is what? This carbon is this. Simple only. Is that clear? H plus KMNO4 can attack double bond also. For example, this is there. CS3, CH, double bond CS2. So very strong oxidizing agent, right? It will break like this. And this will turn into what? CS3, COOH. Plus HCOOH. Is that clear, Nihar?
Yes, sir.
ठीक है, बस तुम याद रखना जो सीओ ग्रुप होगा कभी पूछ लेते हैं सीओ ग्रुप कहाँ जा रहा है, इवन इन नीट. So this CO group will remain with the smaller alkyl group. Is that clear? And both will form number of carbon atoms you cannot increase. Both will form what? Acids. Here also both will form what? Acids. Is that clear? This is not that stable, so it breaks into CO2.
So those the acid, if it's methanoic acid, it'll further oxidize to CO2 and H2O, right?
Right. It will break down into CO2 plus H2O.
And CH3COH remains the same.
CS3?
Like acetic acid just remains.
Yeah, it remains.
Okay.
Sometimes formic acid is also actually first H2CO3 is also formed. So that breaks into H2, but that is fine. You can take it as CO2 plus H2O. Is that fine?
Okay, sir. Yeah.
Okay, guys, all the best. Put your doubts, all of the people. The point of this class was just to revise on how things work and to take your doubts if there are any. Okay. So please revise. Yeah. Somebody was asking something? No? Okay, guys, then you can leave. All the best.
Thank you, sir.
Thank you, sir. Yeah, put your
Thank you,
doubts
sir.
on people if there are any.
Thank you, sir.
Thank you.